Hi everyone, I'm Thomas Fauché, one of the workshop SOC member and the TIE lead. Welcome to TIE, we are very happy to have you on board. We have almost 80 people that have expressed their interest for the workshop so far, and so we really hope to see you all from September 14. And so the objective of this video is to explain what is TIE, where it came from, and what are the available resources. So first of all, this website, if you look at the agenda, you can already see the list of the pre-recorded talks that will be all uploaded from September 4th. So it's very important to watch these talks before the workshop because the workshop will be only about live discussion and breakout discussion. Every talks are pre-recorded. So once they will be uploaded, you will be able to comment and ask questions to the speakers directly under the video. We have also a list of the breakout session already available. On the website, you can subscribe to one breakout per day. We have a maximum of 10 people per breakout, and so first come, first serve. All right, so now I'm going to give you a little bit more information about TIE itself. So TIE was born during the Habitable World Conference 2017 in Laramie, Wyoming. So during this conference, there was several talks about GCM simulation for exoplanets. And one of the attendees, David Charbonneau, asked this question: how can we trust this model? I mean, do they agree between each other or not? And that's a very fair question, actually. And to know that, we need to run an intercomparison. And so I was unfortunately not at this conference, but one of our SOC member, Ravi Koparapu, organized a dinner at a conference to get together all the GCM modelers. And so we have a representation from people all across the world in different groups, but mostly using 4 different GCM: the ExoCam, the NMD, the Rocky 3D, and the Unify models. And so the acronym TIE as well came from this restaurant, because we are going to simulate the TRAPPIST-1E atmosphere, and the interconference was born in this restaurant. So let's do TIE, TRAPPIST Habitable Atmosphere Intercomparison. So thank you, François Forget, for this great idea. All right, so no more detail about TIE. TIE, as I said, is an intercomparison for exoplanet studies. So on Earth, we have a lot of GCM intercomparison for Earth climate and the future changes. And you have also some intercomparison for Venus, I guess, and Mars, and only one for exoplanets led by Jun Yang, but with different objectives. Here, the objectives are really to compare differences on simulated observation. Because you have probably noticed every time we have a new rocky planet discovered in the habitable zone of its host star, it's really a rush from the community to be the first to simulate the atmosphere of this planet. And so that's great, I mean, but we need to be sure that the conclusion given by a given GCM are not model dependent. So to know that, we need first to benchmark all the GCM together in order to have a unique answer. And so we also need a good benchmark to do this intercomparison, and TRAPPIST-1E is probably the best because it's one of the most famous targets for atmospheric characterization with James Webb, and it basically has the strongest transit depth you can imagine because the star is very small. As I said, we have 4 different GCM on board of the intercomparison so far. The ExoCam model that is developed by Eric Wolf at Colorado University, which is the exoplanet version of the CAM, the NCAR model. We have the LMD generic model, which is the exoplanet version of the LMD-Z. Rocky 3D is the exoplanet version of the Model-E at GIS, and finally the Unify model at Met Office. We also thought about different atmospheric composition to do this intercomparison. And you can see we have a central symmetry there. On the left, you have the benchmark cases where TRAPPIST-1E is assumed to be completely dry, no water on the surface. And on the right, you have the habitable cases where the planet is fully covered by an ocean. But they share the same atmospheric composition, either modern Earth or CO2-dominated atmospheres. Of course, for the habitable cases, you have also water in the atmosphere. Okay, now a little bit more detail about the workshop itself. So the scientific organizing committee is constituted of myself, Sean Domagal-Goldman, Ravi Koparapu at Goddard, Linda Sol at GIS, Martin Turby at Geneva Observatory, Michael Way at GIS, Eric Wolf at Colorado University. And you have also a meeting facilitator, Andy Burnett. So Andy has done a really amazing job to build this website, and is also helping us to structure the workshop in order to give you the best experience as possible. All right, so now I'm going to stop sharing this screen, and I'm going to show you very quickly the different resources that we have for TIE. All right, first of all, our protocol paper, which is very important for an intercomparison. So it's been published this year in GMD. And so if you scroll a little bit down, you will find a table here, which is our protocol table that basically gives you all the inputs that you need to have in your model if you want to also compare with the current model in this intercomparison. And a little bit more down, and you will see the table for all the relevant outputs that you also want to have in order to compare with the existing GCM in this intercomparison. Another very important resource here that we have is the Reptile repository. So we have all our GCM data stored here. We have 20 different data sets. As you can see, they are sorted by the name of the TIE case underscore the model. So if I click here, for example, the HAB1 case with a unified model, if you click on Explore, then you're going to download the netcdf file from the GCM. So it's a very heavy and complex file. But if you click here, you will see for the first chunk of orbit, 1 to 10, a description of each parameter that you have in this file. And so that's very important if you want to compare with your own model. Finally, we have also this GitHub here, administrated by Denis Sergeev at Exeter University. So Denis has done a really amazing job to write very efficient Python script for the data processing and the figures. He's also administrated this website. We will have also all our input files will be stored on this GitHub as well. So these 3 resources, we will put a link under the video in order you can access them later. All right, I'm going to stop sharing this as well. And that's all for me. I hope to see you all from September 14. Thank you. Bye-bye.